What if the very thing we fear, the impact of an asteroid, was actually the spark of life? It's a wild idea, but one that scientists around the world are taking more and more seriously. Could it be that the origins of life on Earth weren't found in volcanoes or ancient oceans, but instead in the icy heart of a distant asteroid? Welcome back to Infinity Beyond, where today we journey into one of the most profound and controversial questions in science. Did life on Earth begin with a rock from space? Let's rewind time. Not just thousands or millions of years, but billions. Roughly 4.5 billion years ago, Earth was a molten hellscape, a violent, unstable planet constantly bombarded by meteors, comets, and asteroids. This period, known as the Late Heavy Bombardment, lasted hundreds of millions of years and reshaped the surface of the Earth many times over. But in that chaos, something miraculous might have happened. As asteroids slammed into our young planet, they didn't just bring destruction, they brought ingredients. In 1969, a meteorite crashed near Murchison, Australia. When scientists examined it, they were shocked to find something extraordinary: amino acids, the fundamental building blocks of proteins and, by extension, life. Since then, researchers have discovered over 70 amino acids in the Murchison meteorite, including several that do not occur naturally on Earth. Even more astonishing, some of them showed a preference for left-handedness, a property known as chirality, which is crucial for the structure of living cells. This discovery sparked a radical theory: panspermia. Panspermia proposes that life, or at least its building blocks, originated not on Earth, but elsewhere in the universe, and were delivered to our planet via meteors, comets, or asteroid fragments. And it's not as far-fetched as it once seemed. In fact, laboratory simulations have shown that amino acids can form in space. Combine that with water-bearing asteroids and icy comets, and you have a perfect delivery system, sending prebiotic chemistry straight to Earth. But it gets even more intriguing. Recent analysis of the Ryugu and Bennu samples, brought back by Hayabusa 2 and OSIRIS-REx, confirmed the presence of organic molecules and hydrated minerals. These are materials that formed in the presence of water, long before Earth cooled down enough to support liquid oceans. Imagine this: before Earth had lakes, rivers, or seas, asteroids were already carrying ice and carbon-based molecules through the solar system, crashing down onto the surface, seeding the planet with the first whispers of life. These weren't just dead rocks, they were cosmic care packages, sent from the stars. So if life didn't originate on Earth, where did it come from? That's the million-dollar question. Some scientists believe the essential ingredients were created in interstellar dust clouds, long before the solar system even formed. These molecules, trapped in icy grains, eventually coalesced into asteroids and comets that became part of our planetary neighborhood. Others take it even further. They propose that microbial life itself might have existed on other planets, like Mars, and was blasted into space by impacts, eventually landing on Earth and surviving the journey. Incredibly, studies have shown that certain bacteria can survive the vacuum of space, extreme radiation, and temperature fluctuations. In 2020, a strain of Deinococcus bacteria was exposed to space for 3 years on the outside of the ISS and survived. So the notion that life could travel across space isn't just speculation, it's experimentally plausible. This changes everything. If life on Earth started with an asteroid, then life elsewhere might be far more common than we ever imagined. It means that every star system with a rocky planet and a few asteroid belts might have its own story of life. Maybe not advanced civilizations, but at the very least, microbial life, riding along on space rocks, waiting to crash into a fertile world. And if panspermia is real, Earth might not be unique. We might be part of a galactic web of life, connected not by communication or technology, but by fragments of rock and ancient molecules drifting between stars. Think about it. You're made of carbon, hydrogen, nitrogen, elements forged in the hearts of stars. But the arrangement of those atoms, the patterns that give rise to cells and consciousness, may have come from somewhere far beyond. You are, quite literally, the child of a cosmic collision. But as we reach for answers, we must also ask, how do we prove it? That's where missions like Mars Sample Return, Europa Clipper, and future asteroid explorers come into play. If we find similar amino acids or organic compounds on Mars, Europa, Enceladus, or even in the subsurface oceans of distant asteroids, it will suggest a shared cosmic ancestry. And that, more than anything, would prove we are not isolated miracles, but part of something much bigger. There's a beautiful irony in all of this. The same forces that have threatened life, asteroid impacts, cosmic radiation, meteor storms, may have also created it. Destruction and creation, chaos and order, extinction and evolution. They are not opposites. They are partners, dancing together across cosmic time. An asteroid killed the dinosaurs. Another may have brought the spark of life. And in a distant future, we may ride aboard asteroids ourselves, using them as shelters, transports, or even launching pads into the deep unknown. In the next episode of Infinity Beyond, we explore one of the most haunting questions of all. What if a massive asteroid is already on its way, and we just haven't seen it yet? Are we truly prepared? Or is a ticking clock already counting down? Make sure to subscribe, share, and stay curious, because the universe is full of secrets, and some of them might just be buried inside a rock.